much for being here. I know we have a lot of tutors who are very excited about learning about math. It can be an intimidating subject sometimes.
Hi, everyone. I'm Lacy, and thanks, Natasha, for that great introduction. First thing I want to say is I think this is a really great organization from what Natasha has told me about it, and I think that the work that you do and the time that you give is really special, so I'm really happy to be here to help make that job easier for you. Okay, so I'm going to jump right in. So my background is with Singapore math, and everybody can see my screen, right?
Yes.
Okay. I guess these are rhetorical questions that I'm just asking myself. Okay, so Singapore math, in a nutshell, is we try to really teach understanding before traditional algorithms. Most of us learned math when we were learning math in a very procedural way, where we were taught how cross this out and put this over here and do this without really understanding what we were doing. So I have on the screen an algebra problem, pretty simple algebra problem. Well, I shouldn't say that. Just an algebra problem. So if you could just take a moment to look at it, and then I'm going to show you the two different, the way that we would teach it, and then the traditional algorithm where we want to teach it and then eventually get to the algorithm underneath my slide. So I'm going to be quiet for about a minute so you can look at the problem and process it.
Did you want me to launch the poll right now?
Okay, we can do that if you like.
Yeah, so we did it as a poll so you can answer. We might have to give you a few minutes to calculate it. But if you have a scratch paper and you want to try to put in your answer and see, I see we have a few coming in. Are you allowed to use a calculator?
Yeah, sure.
Okay.
Yes.
I'll give you 10 more seconds. Okay, so this is the results we had.
Can you see that? Can you see that?
Yeah, they can see that. Yeah.
Oh, okay.
So most people said 14, and that's a good thing. And don't worry if you didn't say 14.
Yeah, don't worry, because I've known from doing this that adults get very nervous about math, especially when I ask them to actually come up with an answer for something. So don't worry, because we were all taught. I know you're all trying to like reach way back into high school and think, oh, what was this about, and where does the X go, and this and that. So this is what we want to do with our children, and I think it's really special that you guys are working one-on-one with your tutors and students, so that you really have a chance to really help them to understand, as opposed to them being in a whole classroom full of students and they won't be able to get the kind of attention that you're able to give them. So, okay, so let me show you how we would teach this the Singapore style way. Okay, so basically Sally has 3 times the amount of stickers as Jerry. So here's Sally and Jerry. Sally has 3 equal units compared to Jerry's. Okay, very, very simple. The students can see that these are equal units. This is called the bar model in Singapore math. Together they have 56 stickers. So I put just a line here to show that together Sally and Jerry has 56 stickers total. So if I see 4 equal units, I know that if I want to find just one of the units, that I have to divide these 4 units into 56. So right here I wrote 4 equal units. You divide 56 by 4, so then you get 14. And that's how many Jerry has. And if I happen to ask how many stickers Sally had, that would be a very easy thing for you to figure out, because you know that this is 14, and 14 3 times would be 42 stickers for Sally. And if you wanted to check it, you could add 42 and 14, and it would equal 56. Now, traditionally, if you were just using the algorithm, this is what it would look like. It's very difficult to explain to children right off the bat that X is any number, and that 3x and x, those don't look like equal units. Over here they are equal units. So it's very easy to explain to a child why each of these would get an equal part of the 56 total. When you're doing the algorithm, you need to talk about balancing both sides of the equation. This 3x and this x make a 4x, and to get this x by itself, you would divide by 4 on each side, so x would equal 14. Now, I know it's all coming back to all of these rules of algebra, but when you're first learning it, just think about how intimidating that would be to try to remember that, and really all of that is basically another language to you. Over here, I would feel much more comfortable explaining this side to my students. Down here I wrote that oftentimes they find what x is and then they forget what x is all about. They don't know about Jerry and Sally, and basically it takes all of the sense making out of the word problems, and word problems are a big deal to many students, and they lose the sense of it, and they're so worried about remembering the procedure that was taught that they forget. They'll sometimes choose, they'll see the 3, they'll see the 56, they'll see the word times, and they'll just say, oh, I'm just going to times it because I don't know what else to do. And they don't use any of their understanding. Okay, so that was just a simple example about basically the main philosophy behind Singapore math is that we do want them to learn this algorithm, but this is how we get there. So when we do teach them the algorithm, these things will make sense to them because they're first grounded in a pictorial concrete model here. Okay, all right. So basically this workshop is going to be going over the 4 operations. No matter what type of math you're teaching, whether you have a kindergarten student or a 5th grade student or an 8th grade student, they're going to have to use adding, subtracting, multiplying, or dividing. So the most important thing to remember is that the 4 operations need to be grounded in a strong foundation of place value. So here's an example. Let me just get a blank page here. Okay, so I was in my son's preschool class the other day, and they were working on how many days they had been in school. And the teacher said, okay, so we've been in school 56 days. And then she said, what 2 numbers make 56? And she's looking for the answer of 5 and 6. Okay, so that's all. I mean, that's finding that 5 and 6 do make 56, but when they get into 1st grade, 2nd grade, and 3rd grade, one of the things that they learn is expanded notation, and one of the problems on the test will be write 56 in expanded notation. This will be choice A, and choice B would be 50 plus 6. Now, I know my son's preschool teacher is not trying to deceive him. I know that. But we need to be very intentional with the words we use when we're teaching children. She really wants to say what 2 digits make the number 56, but really 2 numbers that make 56 are 50 and 6, and that's really the value of the 5 is not really 5. The value of the 5 is 50, and the value of the 6 is 6. We use those 2 words a lot when I'm talking about numbers. I talk about either digits or the value of the digit. So when I go back to my operations, when we introduce addition and subtraction, if you're teaching K1 and 2, I really suggest that you use counters when you are doing it with your students. Natasha had a great idea with just like carrying a bag of beans with you or any type of counting objects, so that children they need to work concretely. So when you're adding like single digits or teen digits, just adding the beans together, making groups of 10, and since we are in a base 10 system and all of our numbers when we regroup is where really the problem starts to come in. Children are pretty happy with adding things together, and as long as they don't have to change the numbers around, they're pretty happy. So I suggest like K1, 2, whenever you're working on adding and subtracting, definitely use counters. I'm going to talk about the regrouping part of it, because that's where I've noticed at my school that that's where all of our misconceptions and the kids start to do crazy stuff. Okay, so we always use a place value chart. Place value chart, you could just simply draw just this, 2 lines and ones, tens, hundreds. If you are in 5th grade, you're going to go to thousands, 10,000s, and keep moving over. I'm going to stick in the hundreds. So basically, children need to understand that when we have a group of 10, so the first thing that we would do is, I guess I should have done this. Let me get a new page, and then I will do this. I will copy it. 127.34. Okay, so the problem was 127 plus 34. Okay, so the first thing that we would need to do with the place value is they need to understand the digit 1 means 100. The digit 2, the value of the digit 2 is really 2 tens, which is 20. And the value of the digit 7 is 7. 1, 2, you know what, let me get my little thing. Hold on just 1 second, we'll make it easier. Okay. Okay, here we go. Okay, 1, 2, 3, 4, and then you would do this with them, and so they're seeing that each of the digits has a different value, okay? And because it's in the, they're in the columns, they should relate that to that digit has a different value than just the number 2. All right. So the first things first is that they need to be very comfortable with putting numbers into a hundreds chart. So this would be 100, 20, and then 7. Oops, 1, 2, 3, 4, 5. Do I have 7? Nope, I need one more. 7, okay. And then I would do the same thing with 34. I would say, okay, let's count them together. 10, 20, 30. The 3 represents 30. And then I would say 31, 32, 33, 34. And of course you can do this very easily with just a piece of paper and pencil with little dots. Okay, then we would say, okay, so they need to understand that 10 ones, and we would count them together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we go, 10. I would circle them and then say that's a 10. So we could regroup that and make 1 10. We could move it over here. You could use different colors if you like. That helps them sometimes. Okay, and then you can show them what's happening over here. So what happened is that we added another 10 there. Do you see it? So we're going to add that 10 here. And how many did we leave over in the ones column? Oh, we left 1 there. So this way these numbers start to make sense to them because they could actually see it and it's concrete to them. Okay, so then we can count, okay, how many 10s do we have now? Well, we have 1, 2, 3, 4, 5, 6 10s. And 3 plus 2 plus 1, that is also 6 10s. And how many hundreds do we have? We still have 100 there. Okay, so the answer would be 161. This is the same thing. So that's basically what I did here, is that I use the colors to show what's left over, and this makes more sense to them. And pretty soon, obviously, you would take away the place value chart, and you can just, and they could rely on the algorithm, but at least there's understanding where these numbers are coming from. Because a lot of times when you get to numbers and you start crossing things out, they're like, where are all these numbers coming from? But if they have a grounding in the place value chart, that shouldn't confuse them as much, or they have something to fall back on.
So I actually had a question on that. Okay. So I'm sitting here, but so would you recommend that if they are kind of getting it most of the time, like they're figuring out these problems, just going back to this, just to, like, if they haven't used this method before, or don't use it in class, and just kind of going back and explaining it that way, even if they're usually getting the answers?
What I would do, if they're very consistent and you see that they're strong with it, I would leave it alone, just because you don't have that much time, and I would rather have you spend more time in areas where they do have problems. This particular part of regrouping and moving to the 10, I've noticed children are fine with this. It's the subtraction part where they fall apart. So definitely, because your time is so short with them, definitely let them go. I wouldn't go back and try to teach them it, because it might confuse them as well. But if you're just introducing it, I definitely recommend starting here. Okay, so let's go to the subtraction. My next slide. Oh no, here it is. Okay, so back to place value. This is the really difficult one. So once again, if there is no regrouping involved, using beans or other things to take away was very good. I'm going to jump right into the regrouping because that's where the problems happen. So basically with this one, I would first put 436 at the top. So let me put the screen shade on. And so we would do this. And this is the number that we're subtracting is 436 minus, what did I minus? Minus 59. Okay. Okay. So this is the problem. So the first thing I would say, okay, so can we put 436 in the place value chart? You would do the same thing as we did before. Here's the 400s. We would count them 100, 200, 300, 400, 410, 420, 430, and then 31, 32, and count them all and put them in the place value chart. And then you would look at the ones and you would say, can I cross out 9 of these ones to take them away? No, you can't, because there's only 6 of them there. Now the problem, they need to understand that there are more ones in 436. In fact, in the number 436, there really are 436 ones, correct? But because of our base 10 system, we are able to regroup that, and they can see 6 ones, but there are some more ones over here. So that's the part that you would need to explain. So I wrote this down. Children must understand that regrouping does not change the value of the number. So sometimes when we learn subtraction, we tell them, okay, you have to cross out the 6 and cross out the 3, and then there's the 2, and this becomes 16. Those are all procedures, and if they forget one of those things, they have nothing to fall back on, because the understanding behind what they're doing is not there. Because it looks like, oh gosh, I'm changing the number 436. They first need to understand that 400 plus 30 plus 6 is 436, and when we change it from 3 tens to 2 tens, that 420 plus 16 is also 436. So a lot of times, before I even do subtraction with regrouping, I just have them regroup numbers without even subtracting anything. So I would just practice, okay, in 436, can we get some more ones? Where can we get some ones from? We can get the ones from the tens. And I would just have them practice crossing out the 3. That means there's only 2 tens left, and we can put the tens over here. And I did it with the blue, my blue pen here, is I crossed out this 10, and then I showed it in blue over here, that we unbundled this group of 10, and then we put those 10 here. And then they can actually count and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So they can see the 16, and they can see it here. And they can actually see the 20, and that's why they're putting the 20 here. They're not just arbitrarily putting numbers anywhere. They're thinking that they could just, we're just crossing out as we please, but there's actually a sense to what's happening. So of course you would continue to do that. So then we would say, okay, now can we cross out? Now can we cross out 9 ones? Yes, we can. So you'd cross them out. And then we would say, okay, so I had 16 of them, but I crossed out 9. How many are left? And then we would write down 7. I'm out of room here. Let me get rid of my screen shade. Stop my page. Okay, so so then you could say, okay, there's 7 left. Now we only have 2 10s, but we need to take away 5 10s. And I always like to say 2 10s and 5 10s just so they always remember it's not a 2 and it's not a 5. It's very hard to break that thinking, especially I found it's much easier to teach them if they've never been taught before. When they go to school and they get different teachers teaching different things, sometimes it's hard to break bad habits. So so then once again I'd say, can we get some more 10s? Well, yeah, inside 100, inside one of these hundreds, there are 10 10s, right? Because then you would kind of go through a little bit about counting groups of 10 if they need that support. And then again, you would bring that over here and you would say, okay, 1, 2, all the way to 10. And then you would cross them out again. So we left 300s. And then if I drew all the 10s here, it would be 12 10s. In the beginning, I like to cross out the 2 and write a 12 just to reinforce that there are 12 and that we added 10 to it as opposed to just drawing the 1. Later on, they can learn that, but I like to make it kind of dramatic. And then we cross out the 5, and there would be 7 left, and then there are 300s there. Okay, so, but in the beginning, this this part over here about the number not changing its value is a really important concept for them to understand. Okay, I'm going to pause it. Is everybody fine with what I've said so far?
Yeah, I don't see any questions coming in. But
oh, okay, great.
If you have a question, please, you can enter it on the side.
Okay, great. All right. Okay.
There was one question. Couple questions. One of the questions we had is, at what grade level do you find that most children can leave the chart and just use algorithms? That's released.
Okay, it's very dependent on the child. I have 5th graders at my school that I still feel like I have to use the pictorial model. So you kind of have to just gauge where they are. Like I said, if they're subtracting and they are doing it consistently, I wouldn't even introduce the model. So I would, for subtracting and addition and subtraction with regrouping, by the end of 2nd grade, according to the California State Standards, they should be mastered by then. But of course, you guys are working with students that are not getting, you know, everything they need because they're moving so much. So it could be much, much later than that.
There was just a comment that they wished they had learned that way.
Oh, that's nice, thanks. Okay, I'm going to move on to multiplication tables. Okay. Okay, so I know that this is a real big issue. I know that I've spoken to many junior high school teachers and high school teachers, and basically they tell me, I don't care if they learn anything else in math, if they could just leave 5th grade knowing their multiplication tables. I mean, it's such a grievance that that's all that they want, because it's such, so many children struggle with this. So, okay, so number 1, memorization. There's no getting around that with multiplication facts, but there are some strategies to get there, to get to the memorization stage. So progression facts. So when I do multiplication tables, it's really important that you focus on not too many at a time and one particular groups, like the 7s or the 8s or the 9s, and don't mix them up until you feel the children are fluent with it. So, so let's say that I'm working with you, you're not very strong with your multiplication tables. I'm just going to start with one. I'm going to kind of go through and see where you are. I circled these here, the 7, the 14, the 35, and the 70, because most of the time 1s and 2s and 5s and 10s the children know well, okay? So, so if I were using flashcards, and flashcards are good, and you can do those very simply on index cards, and you can do them right when you're there with your student. I would just do like 1 times 7, 1 times 2, and do all the 1s. And if they are good with that, keep that in a pile. And then I would do the 2s. If they are fluent with that, which usually they are, the 1s and the 2s are usually fine, I could mix those two together, and then I would quiz them on, I would flash them on those two alone. 3 and 4 are problems, and obviously 6, 7, 8, and 9 are the big issues. So let's see, I've tested you on the 1s and the 2s. You're great doing that. I have my pile of index cards with just those facts on them, and I've done them all, like all the digits. So 1 times 1, 1 times 2, 1 times 3, etc. And same with the 2s. Okay, so I've gone through it and I've noticed, okay, so you're a little bit weak on your 7s. What I'm going to do with you is I'm going to say, okay, let's skip count by 7s. You can use a hundreds chart. They could count on their fingers. A lot of, I think one of the old school things is not to use the fingers because that was considered bad, but basically it's like built-in counters that they get to take with them wherever they go. So definitely use those as a tool, okay? Because they're not always going to have beans, they're not always going to have like other things, but their fingers are there with them always. So I would make a list with them, just like I've done here, and we'd write down 7. Okay, 7 and 7 more. Also, you've also kind of, I'm going to backtrack a little bit. Multiplication is repeated addition, and basically they're equal groups. So in between each of these numbers is 7 more numbers, and 7 numbers and 7 numbers. So that's something they also need to understand. So I would do like a little mini lesson before I even got into this, that multiplication are just adding equal groups over and over again, and these are the numbers. So I would say like 7 plus 0 is 7, 7 plus 7 is 14, 7 plus 7 plus 7 is 21, and then keep going. So I want them to see that it's groups of 7 over and over again. Okay. Okay, so then we would go through and write down the multiples of 7, just like I've done, and we would make a list. And so what I would do is I would let them look at this list, and maybe, so I've written, okay, this is 7, this is 7, plus 7, this is 7, plus 7, plus, okay, and then of course you're going to do this, you'll spread out your numbers, and you'll make it much easier than that as it goes on. You can even, after that, maybe down here it would be 7, so they can correlate that 7 times 1, which means it's 1, 7, 7 times 2 is 2 7s, and you would keep going along, okay? And then you would have these in the center, and then what I would do is I would have the 7s on a flashcard, 7 times 1, 7 times 2, and I would let them look at the list so that they have the answers in front of them, at the whole list. So when they see 7 times 5, if they don't know it, they could just count 1, 2, 3, 4, 5, and they could see it's 35 and say it, okay? So I would do that drill, letting them have the answers in their hand, because if they memorize it, that's great, right? And so you would go through your 7s with the flashcards, and they would be looking at the answers, and they would tell you 56, 63, whatever it is. Okay, so the great thing about progression facts and them understanding that 7 plus 7 plus 7 is 21 and that 7 times 4 is just another 7 is that if they don't know 7 times 6, but they do know 7 times 5, which a lot of them will know 7 times 5, that they could just put 7 fingers up and say 35, 36, 37, 38, 39, 40, 41, 42. It gives them something at least to fall back on if they don't know it. If they don't know 7 times 6, then they just are sitting there. But this, if you show them that it's, if you write this out in a chart and they could see that's just another 7 every single time that they go to the next number, it's a progression. Okay, so that's the progression facts. My dots down here is another good way to, this is kind of fun too, for them to make arrays. Now arrays are, they're basically multiplication tables. So you can give them, let's see, so 28 beans and tell them to make a 4 times 7 is 4 rows of 7 or 7 rows of 4, okay? So they can sit there with their beans on the table and make the box. And it also lets them know that I put the commutative property here, which is a big word for basically saying that either way is the same answer. Addition and multiplication are like that. So give them the power that they're learning they know if they know the answer to 7 times 4, they know the answer to 4 times 7. And sometimes that gives them a little boost of like, wow, I'm doing double the work and I really only have to figure out these other ones. So this is a fun activity also. It gets them kind of involved because they're moving the beans around in these different arrays. And you can do that with you can do 3 times 4. So you can tell them to make 3 rows of 4 or 4 rows of 3. And sometimes kids need just a visual and it'll stick to that. Okay, and then the intentional practice. So, okay, so once they've done all of their 7s, and I think they're really good with 7s, I have my 1s and my 2 flashcards sitting there. I'm going to put the 7s just with the 1s and the 2s. I'm not going to mix them with the 8s and the 9s yet. And this way you also want to build their confidence that they can do it. And then every week that you go, you can add more to the cards that they know. And you know what, if they slip, then go through the 7s again and write out the multiples of 7 and then review them that way. So like I said, multiplication facts are memorization, but there's some different ways that you could do it, and I hope that gave you a few ideas. Okay, how are we doing on time? Okay, great. Okay, I have you guys for another half an hour, so I'm going to move on to, okay, so these are just multiplication facts, but I'm going to move on now to multiplication with double-digit numbers. And once again, they're going to have to know their place value, okay? I'm going to do this one over here first. You can do it with me. Is when you ask a 3rd grader, let's say, because that's when they start really to get into this type of multiplication, is they'll tell you 4 times 3 is 12. So you put the 2 here, and then you put the 1 up here. And then they'll say 4 times 5 is 20, and then 1 more is 21. And then they'll say, okay, and then you have to put a 0 here. And I've asked them, why do you put the 0 there? And they say, you just do it. And they have no reason why they put the 0 there. So they just say, you just have to do it or else it is wrong. So then they'll say 2 times 3 is 6. And then 2 times 5 is 10. But the 1 is up there from before, and sometimes they get confused about what do I do with that 1, because they forget that they've done it, and so it gets a little confusing. But if you're lucky, they'll say it's 10, and then they'll say, okay, then you have to add these together, and then you get the answer. Whoops. Yikes. Okay. Oops, sorry. My penmanship is better in real life. Okay. So this is wonderful, and this is exactly what we want them to do, but getting here and having them understand where the numbers come, if they forget one of these steps, they're going to be in a lot of trouble. And like I said, when you start carrying numbers up here, I've seen kids do all kinds of crazy stuff. They want to add it, they want to multiply it again. So, so this is how we teach long multiplication in the beginning, okay? They have to realize that these digits, the 3 and the 4, is you're really saying 4 times 3. So over here, it's 3 times 4, and we write it down in this little T chart over here, okay? And we say, okay, 3 times 4 is 12. I'm going to write that here. Good. Okay, next we're going to multiply this 4 and this 5 over here, but this, what does this 5, what's the value of this 5? The value of the 5 is really 50, right? So it's really, oops, I should have changed this one around. Sorry, everybody. We did 4 times 3. Okay, so then we're going to do 4 50s. Okay, we did 4 3s, and now we're going to do 4 50s. So we write that over here so we can see what we're doing. Okay, so for your 4th and your 5th grade students, I hope that they're okay at doing this type of multiplication, that 4 times 5 is 20 with another 0, but that's again another place value lesson, why you can do that, okay? So I'm going to assume that they've had that lesson and they're moving on, so that would be 200, okay? So we would write 200. Okay. Then I could show them, okay, so if I add 212 together, this two numbers, do you see 212 in the standard algorithm? It's right here. Okay, so they could see that, okay, what's happening there. And I haven't carried any numbers or done anything crazy. Okay, so then we can say, okay, so we did 4 3s and 4 50s. But now we're going to go over to this 2. What is the value of this 2? And the value of the 2 is really 20. So this time we're going to really say there's 20, I want 23s. I mean, yeah, 3 20s or 23s. So we would write 20 times 3. And well, 20 times 3 is 60. And then I would do 20 times 50. And you can tell them the reason why you put the placeholder there is because you're not, it's a shortcut that when you're saying 2 times 3 and 2 times 5, you're really saying 20 times 3 and 20 times 5, and they could see that over here. And that's why there's a placeholder there with the 0, because it's not 2, it's 20. And then if we had hundreds, there would be 2 zeros on the bottom because we would be multiplying by 100 times each of the numbers. So it'd be 20 times 50 would be 1,000.
So I just had a question. So would you recommend then doing the left side, like writing out the left side, even if they couldn't do it, that you do it beforehand just to show them?
Yeah, I do this. Okay, so I would do this a couple times with maybe not. I wouldn't do it with 2 digits, maybe just 1 digit here to show them this. But when I'm trying to move them to the algorithm to the left side, I definitely want to do the problem side by side because they need to see where the numbers are coming from. Okay. And then I would say, okay, so do you see the 1,060 that we did here? Okay, and then I would circle it and show them, yes, 1,060 is 1,060. And we had to put that 0 here because of these 2 zeros here, and because this is really 20 here, not just 2. Okay, so, and then I would, then we would draw the line, and then we would add it up, and I would show them that it's the same. Now you would do this much neater on a piece of paper so all of the numbers are lined up evenly. Okay? All right. Okay, so that's double digit explaining it. So if you have bigger numbers with hundreds, and I noticed that children, when they get to these big numbers, they forget that multiplication and division are just making equal groups. Like it's worthwhile for you to say, okay, so I want 24 groups of 53. Would that be really hard to count? So always bring it back to what's happening in the first place. Like after you finish this, they're probably going to be exhausted and need to take like a snack break or something. But they need to remember that they're just making 53 groups of 24. And what I always do too is if I feel like they've lost what they're doing, I just say, well, remember I would just bring it to a much smaller, like to 3, and I would say, okay, so if I had 3 times 2, what does that really mean? It just really means that I want 2 groups of 3, and I would use beans, or I would draw a picture, and so I would always bring it back to that, and then bring it back to whatever you're doing, 54 times 23. So I would also put these side by side so that they don't get scared by the bigger numbers and just say, okay, so just like I wanted 2 groups of 3, I want 23 groups of 54. This is just really big, and for me to count that would take a long time, so that's why we need to use multiplication, and we need to learn how to first do 3 groups of 4 and then 3 groups of 50 and bring it back that way. Okay. The last thing I'm going to show you tonight is is division, long division. And long division is also making equal groups, right? Except you're dividing a number into equal groups. So for this problem here, I want 4 groups, and I have 532 things. So before I would start here, I would also do an easier problem. So I would say, like, if I want 4 groups, I always try to ground it into something they know, and don't be afraid to pull it down to something really easy to kind of relate it to the bigger numbers and the hard things. So I would say, okay, so I have 12 things, 12 candies, and there's 4 people. I wonder how many candies each person would get so that it would be fit. Whoops, yikes. Okay. And then something like this is very simple, that they could either keep counting 1, 2, 3, 4. Okay, they each have a candy. Are there more candies to give out? Yes, we haven't gotten to 12 yet, so let's give everybody another candy. 5, 6, 7, 8. Did we use all candies yet? No. And so I want them to always know that dividing is still making equal groups. Okay, so everybody gets 3 candies. That's great. So when we divide 12 into 4 equal groups, then it's 3 candies each. And then I would go back to my double digit one, and we still need to make equal groups. So he goes, now we have 432 candies and we have 4 groups. So it would take us a really long time to put 1 candy in each person's bag for Halloween. So let's put our numbers in. Let's put our numbers in a place value chart. Okay, so what I would do is, oops. Okay, so we would start with 500. So let's count together 100, 200, 300, 400, 500, 510, 520, 530, 531, 532. Okay. So this is what we do in long division. So can you make a group of 4 out of the hundreds? And they should say, yes, I see 4 right here. Okay, so let's circle, whoops. Let's circle that group of 4. How many groups did we make? We made 1 group of 4. Okay, we made one group of 4. There's 4 in that group, and how many are left over in the hundreds? Oh, it's doing that. How many are left over in the hundreds? Oh, I see. There's just 1 left there. Can we make another group of 4? No, we can't. So I'm going to take these hundreds, and I'm going to break it apart, because remember how we said 10 tens is 100? So I'm going to move it over here, and I'm going to make 10 tens. So I would count 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I would make sure that I count it like that so they understand that this one dot, when you take it apart, that there's 10 tens in there and that these are just hundreds, and so you just moved it over. Okay, so, and I would also cross it out. Okay, so I'd say, oh, okay, so now how many tens do we have after we broke apart the 10 tens here? And then you would count each one of them, and you would discover that there were 13 and say, oh, okay, so I could say, put this 3 here, because now there are 13 tens. Like, okay, now can we make a group of 4 out of the tens? Well, yeah, we could probably make a couple. I see a group here, and I see a group here, and I see a group here. How many groups did we make? We made 3 groups. And 3 groups, so then there's 4 in each group, so that means it would be 3 times 4, because instead of counting all of them, I know it's 4 plus 4 plus 4, or I can say 3 times 4. And I would show them that I'm doing the 3 and the 4, okay? And so in those groups we had 12 dots. And how many dots are left in the tens? Well, there's the 1 dot there. 1 10 is left. Okay, can I make another group of 4? I can't. So I'm going to take this 10, and I know that inside this 10, there are 10 ones in it. Okay, and then, and so you would do it again and count, okay, 1, whoops. Okay, so then you would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you would do the same thing, and you would circle the groups of 4. One, 2. How many groups did we make? We made 3 groups. Oh, I'm sorry. Before you do that, you would count your dots. You would see that there were 12 after you did the 10. You would bring down the 2. You would then count your groups. There are 3 groups. 3 times 4 is 12. And are there any dots left over? There aren't any dots left over. And this works with remainders as well. If there was a remainder, then you'd put remainder, however many dots are left over. Obviously, when you do this, if you do this kind of example, you're going to have to work it out beforehand, because you don't want to, if there were a whole bunch of dots over here, you would have, if there was like, let's say the number was 732, you don't want to be drawing 30 dots over here and circling the 4. So this format is just so that they know what's happening in all of these areas and how you're getting the numbers up here and why you're multiplying 3 times 4. So after they understand this, and after you've already worked out these examples so they work out very nicely for you, so you could just only transfer 10 over, then you would work on just doing the algorithm. Okay.
Cool, I really like that. I had no idea. I'm sure a lot of our tutors didn't as well. So, and I just want to open it up for any questions. We have about 10 minutes left. We can see if people have specific questions, if They wanted any clarifications on what we presented. I don't see anything yet, so if you want to.
Okay. Keep talking. Okay. Okay, so let's see, what else can I share with you guys? If you're working with a lot of K and 1 and 2 students, working with new page. Okay, so working with small numbers and numbers to 10, I like to use. Let me see. I like to use 10 frames a lot. 10 frames are good because we are a base 10 system. And so this is just a little. Oops. Oops. Okay. Oops. Okay. Okay. So a good activity for them would be to just have 10 squares like this with beans. And I like to, oh, what happened there? Okay. I don't know what happened. But you'd put the beans in the 10 frames, and so you could say, I don't know why that one's so big. So you'd put the beans in there and you'd say, okay, how many beans do you see? 3. How many more do you need to make 10? And they could say 7. Okay, so I do a lot of fluency work with numbers to 10 and then 10 and over. So using 10 frames like this in getting to know number sense and knowing their combinations to 10 is very helpful for them. Any kind of number sense drills, like if you are tutoring and you have just a little bit of time left over to do kind of quick number sense drills will really help them, because I've noticed that a lot of students are really kind of weak in doing certain types of calculations. Like their number sense isn't good. Like every time you subtract, you're always subtracting a teen number, like back from, let me see if I can find my subtraction slide. Okay, so if you notice that when you're doing subtraction, and as they get into 3rd and 4th and 5th grade, they have 10,000s minus hundreds. You'll notice that they're always subtracting. Whenever you're regrouping, it's always a teen number minus a single digit number. So it's 16 minus 9 here, and 12 minus 5. That alone, you can't imagine how many of my 5th graders are struggling with 16 minus 9 or 12 minus 5. So that could be grounded in using using 2 10 frames. So let me see if I made another one. So you would have 2 10 frames, and if you put the dots in them, you could fill up one whole 10 frame. I don't know why the dots are so big, but you'd be using beans that are all. So you'd fill up one whole 10 frame, and then you would add another one. Okay, so you'd say 10 and 1 is 11, and then 10 and 2. And then what you do is say, what's 11 minus 5? And so you want them to visualize they're taking the whole 5 away, and what's left, there's 6 left. If you can say, and here's 12, what's 10 and 2? 10 and 2 is 12, take away 5. So I would always take away 5 so that at the beginning, and then you can try different ones like take away 6, take away 7. So you want them to have visuals and be able to do it automatically, any kind of teen number minus a single digit number, which will help them tremendously every time that they do any type of subtraction. Okay, that was the extra little bit.
We have a couple questions.
Okay.
I don't know if we have a lot of time to answer them, but we can maybe we can answer them by email. Let's see. We have how would you explain decimals? And is that just too much of a to add in 3 minutes or less?
Yeah, fractions and decimals and percents are all related because they all talk about parts of a whole number. So that would be a whole another workshop, I think. They all go in concert together. If I were teaching decimals, they have to understand about fractions and decimals and percents. That anything after the decimal is part of the next number. One thing you have to right away with a decimal number is that you can't, they have to understand that the value of anything behind the decimal is only part of the next number. So they will see a number like 7.8967. They'll see this number, and then they'll see the number 9. And you ask them, okay, what number is bigger, 7.8967 or 9? And almost many times they're going to pick this number because look at how many digits there are. That's got to be a big number. So that's one of the things about decimals you have to talk about right away. That all of this, and I use a number line a lot. So I would drill them. I would put a bunch of decimals and see if they could place it on a number line, and I would just draw a number line and have them draw arrows. So that's one of the big things about decimals.
Okay. And we had another comment and question. Says a compliment. This is really clear and beautifully presented. It seems that it assumes that they know the underlying math, like when they begin to multiply, they can add well. But what do you advise when the problem involves something that they haven't mastered, which is very common with our students, obviously?
Okay, so so if they haven't mastered something, you definitely have to take steps backwards. And if, let's say, you're working on like they bring home their homework and they have this page of math problems to do, when in doubt, look at the problem and always try to go back 5 steps. Like if it's a double digit, like kind of like how I did here on the slide, was that if you see this problem here, always take it back to something easier, and even though it take a long time, you probably will only be able to do like 2 problems on their math page. I would definitely start here and then try to work them up. So whenever in doubt, just take that problem and make a super easy one and try to explain why, and then relate it to the harder problem that they're actually doing in class.
Just one more maybe we'll address tonight, but we can also maybe they can email you some questions.
Okay.
After.
Okay.
That's okay.
Sure.
But we have do you have any other number sense drills for kindergarten or maybe kindergarten first grade than what you showed?
Yes, I have. Okay, some of them involve like using some manipulatives. So I'm not sure if you guys are familiar with Unifix cubes or those connecting blocks. They're like, I don't have a picture. I could maybe Google one, but maybe what I can do is for K1 and 2, I can put together a few ideas, and then with a picture of it, and then I can email it to Natasha, and she could get it out to everybody that would want something like that.
Yeah, that would be great. Yeah, and just a reminder, we're going to post the recording of this workshop on our website, and we can put materials with it. So if Lacy has anything else that she can forward, we'll put that up there, and I'll email you to let you know when it's up. But I think we're sort of out of time tonight,
okay.
But it sounds like people really appreciated it. We had a comment too about that someone just recently got their teaching credential, but they never saw it taught this way, and they really thanked you for doing that, because I think this is a specific way that not all teachers are trained in. Yeah, so we have to recognize that that you can't expect this to all take place in the classroom. That that as we as tutors are trying to help that and trying to fill in those gaps by going back and covering these steps in a different way. That this way it just really seems like it works for a lot of students, especially students who are behind.
Yeah. Mm-hmm.
So that's all we have. I really like to thank Lacy for coming here and talking to you guys, and she just volunteered her time, and I appreciate that, and just as you guys are volunteering your time, we appreciate that too. So thank you. We do have another workshop coming up on December 5th, that's Wednesday. It's actually a lunchtime workshop, and it's going to be by our Learning Center coordinator, Allison Maldonado, and she's going to be just answering general questions about personalizing learning plans and strategies, behavior tips, anything that's on your mind. So if you can kind of log in during lunchtime from 12 to 1 on December 5th, that's going to be a great workshop if you have questions. So thank you all, and have a good night.